Hey everyone. So, like I've mentioned on Remind and on Google Classroom, I was going to begin doing some screencasts on the day-to-day assignments everyone should be uh, completing for this week. So here for this video, I'm going to go over days 1 through 4, so the entire week's packet. I hope to get this in the time frame of 20 minutes, but I'm going to do the best I can because you know me, I always like to talk. So I will try to cut that down. But I hope everyone is doing well. So, without further ado, let's go ahead and begin. So, for day one, this is kind of similar to what you guys seen, what everyone has seen on the packets for the first week or for the first phase of online learning or distance learning. So, you should know already what to do here. So, sketch notes on the different types of reactions. But if you've already finished that and you've turned that in for your first packet, then you're going to move on to the mind map. Okay, you will be following these directions. Complete a mind map of chemical reactions. Your mind map should include all 5 types of chemical reactions. Your topic should be in the middle of the page with your different types of reactions branching out. And then you look at the example obviously below here. So what I am looking for and what I am expecting, let me go ahead and set this up real quick. So, for example, decomposition. Okay, I want to see. Where's my pen? Up there it is. What I want to end up seeing is I want this to branch out, and I want you to tell me one interesting fact of about decomposition. Tell me the definition. Tell me what's the general equation. I want you to tell me what's an example of the following reaction, and then so on and so forth. I want to see at least 4 branches for each. Okay. If you've already done this and you've went far above and beyond, awesome. Good job. But if you haven't, it's okay. You have some time to fix that. All right. So that's what I'm looking for here. I need it for each single reaction. Okay. The branches could be different. It could be a different, criteria, but these are just 3 examples of what that can help you complete the assignment. Okay. And then from here, after you told me what an example is for decomposition, you could branch out further. Is that example harmful for the environment? Can it kill someone? Can if you inhale too much of it? So, like for example, chlorine gas. If we inhale too much chlorine gas in one sitting, that could leave us unconscious, and then ultimately, we could perish. It's not a good chemical and a breathing situation. So we don't want that. So like that's what I'm talking about. From the example, what is like a quality of it? Is it like for example, if you say decomposition, say the breakdown of carbohydrates, so carbs, the way that carbs are broken down, that's used in the decomposition reaction. Well, for carbs, what are carbs used for? They're used for energy. Okay, so this is what I'm talking about. Okay? So here's my branch. I'm branching to carb. Okay, and then I have my box on carb. Come on now, that's too thick. There you go. And then here I branched out again, and I branched to energy. Okay, so that's just an example of what I'm looking for. Okay, but again, if you need some more time to work on this, that's fine, because day one assignment is due, I believe, on Monday or Tuesday. I have to take a look again. Bear with me, ladies and gentlemen. Should be real quick. Yep, phase 2 day 1 assignment should be due on Monday. Then phase 2 day 2 should be due Tuesday. Day 3 do Wednesday, and day 4 do Thursday. Okay. So let's go ahead and continue on forward. For day 2, we're going to be balancing chemical reactions. So for this assignment, go ahead and lower down the thickness. Same thing that we've been working on for the past few weeks. You're going to balance the reactions from A through E, and you're going to tell me what type of reaction is occurring. Okay. So I'm going to go ahead and help you with letter A. So right away when we're doing these type of reactions, remember we want to identify the general equation. Okay. So remember there's R plus S gives us RS. RS plus T gives us RT plus S. And we have, let's see, RS decomposes and gives us R plus S. And we have, drawing a blank here. Oh, yeah. RS plus TU gives us RU plus TS. And last but not least, we have CXHX plus O2 gives us H2O and carbon dioxide. Okay, so these are the 5 different equations that we kind of want to keep in mind when we're doing these problems. Okay, we want to take each of these equations. Okay, it's this way. We want to take each of these equations and we want to identify which elements in here are R and which elements are S and which elements are T and which elements are U, depending on how many elements or atoms you have in the balance or in the chemical equation. Okay, so with that beginning explanation, let's go ahead and do letter A. So here I have sodium and A, so I could say that's my first element. I could say R, and sodium's with another element. It's bonded together with bromine. So I could say that's my S. Okay. Calcium, it's another element or atom that's bonded together with another set of elements. So this, I could say this is my T, and then this is my U. Okay. And let's keep going. Calcium, we said calcium was what? Was our T. Bromine was our S. Okay. Sodium was our R. And then OH, we said, was our U. Okay. So we could see that there was some switching going on. Right? The T's and the R's switch places and they swap partners. So we have TS, and over here on the right, we see TS on the right, RU, RU, RS, RS, TU, TU. So by the look of things, this should be a double replacement reaction. Okay, by now you should know how to do this. Okay, lead on your own. Okay, so let's go with letter D. Okay, so same thing that we did before. We are going to go with each element, an atom, and we're going to label R, S, T, and U. So PB, right away we can say that's an R. Okay. H, that's all by itself. So we could say that it is a T. Okay. Notice how I didn't say it's an S. Okay. S's are reserved for elements that are either by themselves. So say if I had something like this, S would be either by itself or S would be together in a compound. Okay. So see here, we only have R by itself, correct? But we don't have another element that's by itself. So again, we're going to reserve that S for when it's by itself or in a compound. By itself, in a compound. Okay. So we have R. Hydrogen, we have our T. And PO4, we're going to serve those together. That's going to be a U. Okay, remember this is called a polyatomic ion. Okay, means that there are more than one atom. Okay, let's move on. So H. Now we're on the right side of the reaction arrow. H, what letter do we designate for it? We said it was a T. PB, we look for PB. Oh, PB was an R. And then PO4, we said was the letter U. So what happened between R and T? Good. Hopefully you answered that in your head. U swapped partners. PB was strong enough to force hydrogen out of its bond with PO4 and replace it in a new compound. So then here we have one single element replacing another element in a compound. So we should know that that is called a single replacement reaction. So here, what you were supposed to do is look at the left column. Okay, so this is where I'm at right now, over here. Left column, you're going to look down, you're going to find the mistake. Okay, each of these are not correct. You have to find the mistake that's given or that is present in each of these reactions. Okay, so you're gonna have to either look for, some of them are balanced. So you're gonna see if they are balanced. I had this written down, but I just second guessed myself. Teachers second guess themselves all the time, guys. Everyone, are they balanced? Are they represented correctly? Are any atoms missing? These are the different types of questions you should be asking yourself. Okay. So let's look at the first one. Here on the first one, they kind of tell you already what's wrong with it. They say that chlorine is supposed to be a diatomic molecule, and it does not exist as a single element. So they're saying that this right here is the mistake. So if it's a diatomic molecule, that's telling me that I should have had to put a Cl2. So then I'm going to go ahead and I'm going to correct it. I'm going to say Mg, I'll bring the states of matter, plus chlorine, and put my gas, should have given me MgCl2. I'm going to say that's my solid. Next thing, I'll have to make sure that it is balanced. Okay, so I'm going to draw a little line here. You can do this on the lower part of the assignment. Doesn't matter, just as long as you complete the right side, every single cell that you see on this table. Okay, so we have Mg. I see that it has 1. Chlorine has 2. Over here, Mg has 1, and chlorine also has 2. So this is a balanced equation. So we are good to go. Okay, so look at the second cell. Okay, so this is number 1. So look at number 2. For number 2, we have to explain what's wrong. Surprisingly, they give us the correct formula. Well, how does this formula look different to this formula over here? Sodium. Oh, we have sodium on both sides. oxygen. We have oxygen on both sides. NaO2. NaO2 we have on both sides. Oh, but look at those numbers. Look at this. That's what's different. They have different coefficients. So over here, the equation is wrong because sodium, or Na, does not. Oh, I should have said sodium and. So this is going to go in here, everyone. Sodium and Na2O. Sodium and Na2O does not have the correct subscripts for the equation. Okay, that's pretty much it. So you will be going through the rest of day 2's assignment and go about trying to figure out what's wrong. A hint for each of these, and it will probably be the more common mistake that you're going to find. Ask yourself, are they missing subscripts? I can't spell. Subscript. Wow, what was that? Subscripts. Man, that was a challenge. Are they? There we go. Are they missing subscripts? Question mark. Okay. Also, remember Hofbrinkel? Don't forget that. That's another hint. All right, I'm not going to say anymore. And then day 3, go ahead and go about here completing the quizzes. Okay. And I know I had a few. Well, what is this? Oh my gosh. Okay. We're not going to worry about that. Don't worry about that, Dog Auto. I know I had a question, and I'm trying to find it. Oh, here it is. So I had a question come to me from another student about this problem number 3. It says, what is the part of the chemical equation in green called? Well, there's no green. So what we're going to do is we're going to change green. Uh-oh, where's my pen? Sorry. Let's go with red. Oh, let's go with green because we're talking about green, right? Half point. Okay. What part of the equation in green what is it called? So I think what the green part was supposed to be over here, because notice how this is the only part that's in different color. So go ahead and let me know what this part of the reaction is called. Okay. Any questions? All right, good. Let's keep going. Let's keep the ball rolling. All right, here we go. Day 4, your reactions quiz. So you can take everything that you learned all this week and from previous weeks that we've learned this, and you are going to answer these questions for the reaction quiz. Okay. And once you are done, make sure to submit these on Google Classroom. Okay. Again, the due dates are day 1 is due on Monday, day 2 due Tuesday, day 3 due Wednesday, and day 4 due next Thursday. And have a good rest of your day.